Voyager 1. Voyager 1 is a space probe launched by NASA on September 5, 1977. Part of the Voyager program to study the outer solar system, Voyager 1 was launched 16 days after its twin, Voyager 2. Having operated for 42 years and 17 days as of September 22, 2019, the spacecraft still communicates with the Deep Space Network to receive routine commands and to transmit data to Earth. At a distance of 21.8 billion kilometers from Earth as of July 11, 2019. It is the most distant man-made object from Earth. The probe's objectives included flybys of Jupiter, Saturn, and Saturn's largest moon, Titan. Although the spacecraft's course could have been altered to include a Pluto encounter by foregoing the Titan flyby, exploration of the Moon took priority because it was known to have a substantial atmosphere. Voyager 1 studied the weather, magnetic fields, and rings of the two planets and was the first probe to provide detailed images of their moons. After completing its primary mission with the flyby of Saturn on November 12, 1980, Voyager 1 became the third of 5 artificial objects to achieve the escape velocity required to leave the solar system. On August 25, 2012, Voyager 1 became the first spacecraft to cross the heliopause and enter the interstellar medium. In a further testament to the robustness of Voyager 1, the Voyager team completed a successful test of the spacecraft's trajectory correction maneuver (TCM) thrusters in late 2017, the first time these thrusters were fired since 1980, a project enabling the mission to be extended by 2 to 3 years. Voyager 1's extended mission is expected to continue until about 2025 when its radioisotope thermoelectric generators will no longer supply enough electric power to operate its scientific instruments. In the 1960s, a grand tour to study the outer planets was proposed, which prompted NASA to begin work on a mission in the early 1970s. Information gathered by the Pioneer 10 spacecraft helped Voyager's engineers design Voyager to cope more effectively with the intense radiation environment around Jupiter. However, shortly before launch, strips of kitchen-grade aluminum foil were applied to certain cabling to further enhance radiation shielding. Initially, Voyager 1 was planned as Mariner 11 of the Mariner program. Due to budget cuts, the mission was scaled back to be a flyby of Jupiter and Saturn and renamed the Mariner Jupiter-Saturn probes. As the program progressed, the name was later changed to Voyager, since the probe designs began to differ greatly from previous Mariner missions. Voyager 1 was constructed by the Jet Propulsion Laboratory. The radio communication system of Voyager 1 was designed to be used up to and beyond the limits of the solar system. The communication system includes a 3.7-meter diameter high-gain Cassegrain antenna to send and receive radio waves via the 3 deep space network stations on the Earth. The craft normally transmits data to Earth over Deep Space Network Channel 18, using a frequency of either 2.3 GHz or 8.4 GHz, while signals from Earth to Voyager are transmitted at 2.1 GHz. When Voyager 1 is unable to communicate directly with the Earth, its digital tape recorder (DTR) can record about 64 kilobytes of data for transmission at another time. Signals from Voyager 1 take over 20 hours to reach Earth. Voyager 1 has 3 radioisotope thermoelectric generators, RTGs, mounted on a boom. Each MHWRTG contains 24 pressed plutonium-238 oxide spheres. The RTGs generated about 470 W of electric power at the time of launch, with the remainder being dissipated as waste heat. The power output of the RTGs declines over time, due to the 87.7-year half-life of the fuel and degradation of T. He thermocouples, but the craft's RTGs will continue to support some of its operations until 2025. As of September 22, 2019, Voyager 1 has 71.73% of the plutonium-238 that it had at launch. By 2050, it will have 56.5% left. Voyager 1's mission included a flyby of Titan, Saturn's largest moon, which had long been known to have an atmosphere. Images taken by Pioneer 11 in 1979 had indicated the atmosphere was substantial and complex, further increasing interest. The Titan flyby occurred as the spacecraft entered the system to avoid any possibility of damage closer to Saturn, compromising observations, and approached to within 6,400 kilometers (4,000 miles), passing behind Titan as seen from Earth and the Sun. On February 17, 1998, Voyager 1 reached a distance of 69 astronomical units from the Sun and overtook Pioneer 10 as the most distant spacecraft from Earth. Traveling at about 17 kilometers per second, it has the fastest heliocentric recession speed of any spacecraft. In December 2017, it was announced that NASA had successfully fired up all 4 of Voyager 1's Trajectory Correction Maneuver (TCM) thrusters for the first time since 1980. The TCM thrusters will be used in the place of a degraded set of jets which were used to help keep the probe's antenna pointed towards the Earth. Use of the TCM thrusters will allow Voyager 1 to continue to transmit data to NASA for 2 to 3 more years. Each Voyager space probe carries a gold-plated audio-visual disc, should the spacecraft ever be found by intelligent life forms from other planetary systems. The disc carries photos of the Earth and its life forms, a range of scientific information, spoken greetings from people such as the Secretary General of the United Nations and the President of the United States, and a medley, Sounds of Earth, that includes the sounds of whales, a baby crying, waves breaking on a shore, and a collection of music including works by Wolfgang Amadeus Mozart, Blind Willie Johnson, Chuck Berry and Valia Bakanska. Other Eastern and Western classics are included, as well as various performances of indigenous music from around the world. The record also contains greetings in 55 different languages. Thanks for watching. Subscribe to Footprints for more videos.